What are the various types of igneous textures and how they are formed, and what are the factors affecting the igneous texture. Igneous texture is regarded as a function of the following parameters. First is crystallinity, second is granularity, third is shapes of crystal, and fourth is mutual relations of crystals or mutual relations of crystals and glassy matter. So these are the four major features or four major parameters on which the igneous texture depends, or by which the igneous texture is affected. The last two factors, that is shapes of crystals and mutual relations of crystals or mutual relation of crystals and classy matters, are sometimes grouped together and called as fabric. So these two last factors are sometimes also called as fabric when they are grouped together. Fabric is essentially, it is basically geometric interrelationship of grains in rock, which means that fabric refers to the spatial arrangement and orientation of grains within the rock. Now first we discuss the crystallinity. Crystallinity refers to the degree of crystallization, or we may define crystallinity as the ratio between the crystallized and non-crystallized matter. It means that crystallinity is the measure that how much crystallized substance or how much crystals are present within the rock. Types of the rocks on the basis of crystallinity. There are three types of rocks on the basis of crystallinity. First is holocrystalline, second is holohyalline, third is microcrystalline, which is also sometimes called as hypocrystalline or hemicrystalline. Now first we discuss that what is holocrystalline. Holocrystalline refers to that rock that is composed totally of crystals. Protonic rocks are usually holocrystalline, while holohyalline refers to that rock having totally glass, which means that holohyalline is composed entirely of the glass. Obsidian is an example of holohyalline rock, where microcrystalline or hypocrystalline or hemicrystalline rock refers to that rock that is partly composed of crystals and partly of glass. So microcrystalline rocks have both crystals and glass. Now what are the factors that affect the crystallinity? First factor is rate of cooling, while second is viscosity. How rate of cooling affect the crystallinity? If rate of cooling is rapid, it means that it is fast, then the rapid rate of cooling of magma promotes the formation of glass. On the other hand, if the rate of cooling is slow, then crystals form. Similarly, viscosity affects crystallinity in such a way that if more viscous magma is present, or magma have more viscosity, then magma with more viscosity will result in formation of glass. Its cooling will result in formation of glass. On the other hand, less viscous magma results in the formation of crystals due to the solidification or due to the cooling. So we can say that the rapid rate of cooling and more viscous or more viscosity promotes the formation of glass. On the other hand, slow rate of cooling and less viscosity promotes the formation of crystals. These are two pictures showing the hypocrystalline and holocrystalline rocks. These are the microscopic features. The left one shows, or it represents, the hypocrystalline rocks, which means that both crystals and glass are present within the rock. Crystals can be identified, they can be distinguished, while the glass is unidentifiable because it don't have any definite shape, and the atoms or the particles are arranged randomly within the glass. Another end, holocrystalline, the right one picture shows the holocrystalline rock, which is composed entirely of crystals. The whole rock is composed of crystal. Now, second parameter that affects the igneous texture is granularity. What is granularity? Granularity refers to the absolute size of crystal or grain. The grain size of crystal in igneous rock ranges from almost submicroscopic dimension, such as macrolites which have less than 0.1 millimeter size to crystals measurable in yards as in some pegmatites. It means that grain size of crystals in igneous ranges, they can be, they varies, they can range from 0.1 millimeter in size to the size that can be measured in yards. So what are the factors that affect the granularity? First factor is viscosity, second is rate of cooling, third is molecular concentration of crystallizing substance in the magma, while the fourth is complexity of system. How viscosity affects the granularity? Viscosity affects the granularity in similar way as it affects the crystallinity. If there is less viscous magma, then there will be formation of coarse grained rock, or the grain size will be coarser. Another end, if more viscous magma is present, then the solidification of more viscous magma will result in the formation of fine grained, or it will result in the grains that will have smaller sizes. Similarly, if rate of cooling is rapid, then fine grained rock will form. Another end, if rate of cooling is slow, then coarse grained rock will form. How molecular concentration of crystallized substance in the magma affects the granularity? More the molecular concentration of crystallizing substance in the magma, larger will be the grain size of that component or of that substance. Another end, those components which are present in very small amount will form small crystals because the available material for their growth is quickly exhausted, while the substance or the component which is present in larger amount have grain size larger because the more material is available for their growth. Complexity of system. How complexity of system, or what is complexity of system and how it affects the granularity? Complexity of system refers to that how many minerals are present within the rock, how many minerals a rock possesses. If a rock is more complex, that it means that it have many minerals such as gabbro, which have plagioclase as well as it contains the pyroxene and sometimes olivine. So gabbro is complex in case of mineralogical composition. So it results, or the gabbroic magma or the gabbroic melt results in the formation of fine grained gabbro rock. Another end, anorthosite, which is a rock that contains more than 90% of plagioclase. So it have the major component is single, that is plagioclase. So such rock that is anorthosite will result in the formation of coarse grained rock or coarse grained texture. Now, what are the types of rocks with respect to granularity or on the basis of granularity? First is phanerocrystalline or phaneritic rock. If the crystals are visible to the naked eye and can be identified without the magnification with the help of microscope or handless, then such rock is termed as phanerocrystalline or phaneritic rock. Another and aphanitic rock refers to that rock in which crystals cannot be identified with the naked eyes, and we need the we need the help of microscope or hand lens. Phanerocrystalline is then divided into four major subcategories. First is coarse-grained rock. Coarse-grained rock or coarse-grained texture refers to that phaneritic rock in which average crystal diameter is greater than the 5 millimeter. So coarse-grained rock is that rock in which average crystal diameter or average crystal size is greater than the 5 millimeter, while medium grained rock refers to that phaneritic rock in which average crystal diameter is between 1 to 5 millimeter, while in fine grained rocks the average crystal diameter is less than 1 millimeter, while in pegmatitic texture or pegmatitic rocks the average crystal diameter is greater than the 10 millimeter. Similarly, aphanetic rocks are subdivided into two categories. One is microcrystalline, other is cryptocrystalline. Microcrystalline refers or it is said to that aphanitic rock in which crystals are visible or they can be identified with the help of microscope. Those aphanitic rocks in which individual crystals are distinguishable with the aid of microscope are termed as macrocrystalline rocks, while cryptocrystalline rocks are those rocks in which individual crystals are too small to be separately distinguished even under the microscope. And in cryptocrystalline, as individual crystals are much smaller and they cannot be identified even under the microscope, so they are studied then with the help of X-rays.